Okay, good evening, everyone. This is Bill Breeden, and I'm conducting a virtual Messier Marathon this evening. Today's April 15th, 2020. However, I am simulating the Messier Marathon that we had back on March 21st, 2020. I conducted it by Zoom, simulating the night sky using Stellarium. That session was not recorded, so I've been asked to share it, so I thought it would be nice to do a redo. This one won't be quite as long as the original was, but I hope you enjoy it nonetheless. I'm going to use this software to simulate the night sky and maybe give people something fun to do, some astronomy to get a little relief from this COVID-19 quarantine that we're all dealing with right now. So I hope you enjoy this little tour of the night sky and this simulated Messier Marathon. Okay, so I am simulating the night sky as seen from Danville, Missouri. It's our dark sky site. And this is set up looking west from a latitude of 38 degrees here in St. Louis, near St. Louis actually. And dominating the western sky tonight is the planet Venus. Let's have a quick look at it here through our finder scope. And then let's go ahead and peer through a low power eyepiece. A little bit less than a degree of field of view. Still not much detail, so let's put in a medium power eyepiece. There we go. Now you can see that Venus is in a half phase. It's really nice to look at through a telescope. You can see Venus from anytime it's up. You can basically see it from anywhere. It's the brightest thing in the sky other than the sun and the moon. So let me return us back to a naked eye view. The naked eye view is about 60 degrees of sky. So Don Mackholz has a list of Messier objects in marathon sequence. And according to that, the first object you should look for during a Messier Marathon is M77 in the constellation Cetus. And the marathon begins with objects in the western sky. And that is by design. You want to catch them before they set. So I believe M77 is way down here, which is why we want to catch it before it sets. So let's look at it through the finder scope first, giving us a field of view of just under 6 degrees. And there's M77. It's a galaxy, magnitude 8.8 according to this software, 8.9 according to Mackholz's list. It's about 60 million light years away. So let's look at it through a low power eyepiece. A low power eyepiece from me in my 8-inch Schmidt-Cassegrain F10 is a field of view of just under a degree and a power of about 65x, which I'm simulating here. This red ring is about it's exactly a half a degree of sky. So the whole screen here is a little bit less than 1 degree of sky, which is about what I get at low power with a 32 millimeter eyepiece. I'm simulating using a Dobsonian with a Telrad. So let's put in a higher power eyepiece, just under half a degree of a field of view, with a 15 millimeter eyepiece, giving me a power of about 130. And you can see that M77 is an elliptical galaxy. Okay, let's return to naked eye field of view. Pull our face away from the eyepiece for a minute and gaze back up at the sky. So let's catch the next object on the list before it sets, and that's M74 in Pisces. Pisces is getting really low. It may be too late. It looks like there's a tree blocking our view. Let's see if this is it. No, that's that Triangulum galaxy. I think we're out of luck. I think M74 is behind a tree and too low in the sky, so we missed that one. It's fun because it really simulates what happens during a real Messier marathon. I mean, you do miss objects. They get too low, or there's a cloud that drifts in front of it. So that does have a tendency to happen. Okay, let's return back to naked eye field. The next object on the list is M33, which we did see over here, the Triangulum galaxy. And let's look at it through the finder scope. The Triangulum galaxy is listed at magnitude 5.7. I doubt that it looks that bright. That indicates it's just within the naked eye possibility of seeing. I've never seen it naked eye, even from a dark sight. Others probably have. So let's put an eyepiece in. Let's go with my low power 32 millimeter eyepiece, just under a degree of a field of view. Okay, let's nudge our Dob there and try to keep the galaxy in view. This galaxy is 3 million light years away, so it's just a little bit closer to Earth than the Andromeda galaxy, which I believe is 2,900,000 light years away. Some catalogs list it as 2.5 million, some as 2.6. This list has it at 2.9 million, but this one here is 3 million, so it's just a little farther away. Okay, let's return to a naked eye view. And we can take a little survey of the night sky here while we're here. Let's turn off the constellations and turn off the helpers. And let's have a little tour of the sky tonight, what we would see on March 21st, 2020 if we were out at the dark site. Venus would be dominating the western sky. Just above it, you have the constellation Taurus with its bright star Aldebaran. And here, due west, is this nice bright star cluster known as the Pleiades, or the Seven Sisters. That's actually a Messier object too. It's M45. So let's look over here toward the southwest. And we turn our view toward these three stars here. This is the belt of Orion. And here's the whole constellation of Orion the Hunter, Betelgeuse, Bellatrix, Rigel, and Saiph. With this smudge here, the Sword of Orion, or the Great Orion Nebula, actually viewable naked eye. Okay, let's turn our view south. And you can see the Milky Way here, and you can also see the brightest star in the sky, known as Sirius, in the constellation Canis Major. See what we see out east, rising. We got the bright star Arcturus clearing the horizon at almost 9 o'clock in the evening. If we look up high in the east, we see Leo with its bright star Regulus, and you see this backward question mark here. I'll show you what that looks like. There's Leo. So Leo is a guidepost of spring. When you see Leo, you know spring is coming or it's here. And now let's have a look toward the north. It's really a shame the northern sky gets ignored a lot by people that live in the northern hemisphere because it's always there, whereas the south is always changing. The north is fascinating though, and I'll tell you why. If you look due north at the same altitude as your latitude, so 38 degrees above our horizon here is this star. That is the North Star. That's Polaris. And you will see that it's at the end of the Little Dipper, at the end of the handle. So I'm going to leave the lines on here for a minute and explain why the north is so awesome, okay? North acts like a giant clock. The North Star is the middle of it. You have the Big Dipper here, you have Cassiopeia here, Cepheus and Draco here. They all turn around Polaris like a big clock, going the wrong way. It's going counterclockwise, okay? The Big Dipper is your seasonal marker, okay? Higher up it is, closer it is to spring. So you get into April, Big Dipper is going to be up here. By the time the Big Dipper comes over here, it's summertime. Down here, it's autumn. And over here, it's wintertime. Now, this is in the early evening. The later it gets, the further around the clock these constellations will move. So, for example, it's March 21st. The Big Dip is the first day, well, it's the third day of spring this year. But it's very early spring, so the Big Dipper hasn't made its way to the top yet. By April, it will have. Or an hour later tonight. So by 10 p.m. tonight, the Big Dipper will be way up here. So these constellations move in this pattern throughout the night and also throughout the year. So 9 p.m. tonight, the Big Dipper's here. 9 p.m. in April, it's going to be more here. 9 p.m. in May, it's going to be more here. June, July, etc. But it will also creep along as the hours progress throughout one night. So, for example, if you want to see what the sky looks like in May, but it's only March, go out about midnight. By 2 o'clock in the morning, you can see June's sky in March. So for practical purposes, most amateur astronomers label the seasonal sky by the early evening hours, because that's when most people are out stargazing. There's people out at 2 o'clock in the morning. More people are out at 9 p.m., so that's what we do. Okay, so that's a tour of the naked eye sky tonight. So we're going to return to our Messier Marathon. Okay, the next object is M31, the Andromeda galaxy, and its two satellite galaxies, M32 and M110. So the Andromeda galaxy is in the west also, and it's getting really low. You can see it naked eye. There's that smudge there. That's the Andromeda galaxy. Let's have a look at it through the finder scope. And you can see the Andromeda galaxy is very big. It's nearly 3 degrees across against the sky. That's the width of 6 full moons. So it's big. It's also bright enough to see from the suburbs, naked eye, if you know right where to look. So you'll see this extra galaxy here and here. This is M32, this is M110. Now, a little bit about the Andromeda galaxy in general. It's 2.9 million light years from Earth. It's very much like the Milky Way. It's about the same size, and it happens to have 2 satellite galaxies, sort of like the Milky Way has the Large and Small Magellanic Clouds. If the solar system were in Andromeda instead of the Milky Way, there would be those two. There would still be 2 Magellanic Clouds. I don't know if we would have called them that. It's very interesting how similar they are. So that's 3 for 1, M32, M31, and M110. So let's find the next object on Don Mackholt's Messier Marathon search sequence list, and that's M52 in Cassiopeia. It's an open cluster. Let's go back to naked eye. Point a little bit more toward the north to see Cassiopeia. And M52, I believe, in March is below and to the right of Cassiopeia. So let's look in this general area and put our finder scope in. There's M52 is over here. So there's our finder scope view. You can't really see it yet. You just see a little smudge. So let's peer through our low power eyepiece. just under a degree of a field of view. And now you get a nice, bright, sparkling group of stars. M52 is listed at 5,000 light years from Earth. Its magnitude is listed at 7.3. So it's just below the threshold of naked eye visibility, but shows up really well in a finder and a low power eyepiece. This makes a good object to look at from the suburbs. Open clusters, they're my favorite. I love open clusters. They're sparkly, they're bright, they're moderately easy to find when you're scanning the sky with binoculars or your finder scope. They show up pretty well from the suburbs. So for public outreach events that aren't way out in the middle of nowhere, they're really accessible. And M52 is no exception. Another good thing about M52 is it's in the northern sky, so it's visible most of the year. So let's look at it through a higher power eyepiece. Let's crank up the magnification to about 130. And in my scope, that would just be under 1/2 of a degree of a field of view. Okay, let's return to naked eye view. And next we're going to search for M103. It's another open cluster in Cassiopeia. I believe M103 is higher up in this region. And let's look through our finder. Is it over here? I see a little cluster of stars. Let's look through our finder here. No, that's the double cluster that I found. I'm looking for M103. Oh, it's not as high up as I thought. It's down here close to one of the stars of the W of Cassiopeia. Okay, low power eyepiece. M103 looks very similar to M52, except its brighter member stars seem to be quite a bit brighter than the ones in M52. M103 is 8,500 light years from Earth. It has a brightness of 7.4, so it's very close to the same as M52's brightness. It has a diameter of 6 arc minutes. So this one would look really good with medium power. So let's do that. With medium power, just under 1/2 a degree of field of view. So there's M103. So what is a Messier Marathon anyway? Well, it's what we're doing here. We're taking this list of 110 deep sky objects called the Messier list, and we're trying to find them all in one night. That's where the marathon comes from. And there's only one time a year where that's possible, and that's near the spring equinox, because the sun happens to be in a part of the sky where there are no Messier objects. So we can catch them all over a single night, starting right at dusk and ending right before the sun rises in the morning. So that's a Messier Marathon. They are a lot of fun. I've been to several real ones outside. No, I've never finished one. The most I've seen in one night is 60. I think I made it to 60, maybe 55. Somewhere around 1 o'clock in the morning, I gave out. I was sleepy and cold. Okay, let's try to find the next one on the list. M76 in Perseus. M76 is a planetary nebula. I think it's in lower Perseus down this way. So let's turn on our hints. Let's use this as a virtual star chart as well as a telescope. I think this is it way down here. Let's see. Yes, there it is, M76. So let's put the finder scope in. And planetary nebulas are very, very small. it's very possible that you won't really see it through the finder. They're too small to be most of the time they're too small to be a good sized smudge. They're going to look more like a faint star through the finder. But if you use a good star chart and you know where you're looking, you can usually figure it out. Even if you miss a couple times, just keep trying. Let's throw in a low power eyepiece. This would give me a field of view of just under a degree, magnification of about 65. And you can see now the M76 is a smudge. Doesn't look like much more than that. Its magnitude is 10.1. And it is 3,400 light years from Earth, and it has a diameter of just 2 arc minutes across. So if you compare that to the full moon, which is 30 arc minutes, you can see that this is a small, teeny tiny object on the sky. And that tells you, once you find it, you need to use medium to high power. So let's go for medium first. There's 133 power. That would be my 15 millimeter eyepiece, approximately. And I might even go for my 9 millimeter eyepiece. It's going to give me just under a third of a degree of field of view. So there's about the view through my 9 millimeter eyepiece. And you just see a brighter, bigger smudge. And you can see it's drifting. At this power, you have to keep nudging your telescope to keep it in the field of view if you don't have a tracking drive. Okay, let's return to naked eye view. And I think we have time for one more object on the list before I end this first session here. M34 in Perseus. This is an open cluster. I think it's about here. There we go. There's M34. So this bright star right here is a good guidepost for Perseus. It's called Merfac. It's a first magnitude star, so it's really pretty bright. So if you look for Cassiopeia, and if it happens to be spring, Perseus is going to be up to the upper right or upper left of Cassiopeia. Look for that bright star Merfac to guide your way around Perseus. And let's put the finder scope. Let's look through that first. And M34 is a nice, bright, pretty star cluster in a really pretty part of the sky. There's a lot of stars in this part of the Milky Way. So you get even if you miss M34 the first time you're searching for it, you're going to be treated to a really nice view. M34 is 1,400 light years from Earth, about the same distance as the Orion Nebula, actually. It has a magnitude of 5.5 according to Don Mackholtz and 5.2 here in the software. So it's a fifth magnitude object. Let's put in a low power eyepiece. Let's nudge our scope. Now M34 is a less dense open cluster than some of the others. And sometimes these sparser ones are actually prettier because you kind of concentrate more on the individual stars instead of the whole cluster. And you begin with some of them to see even hints of color, gold, maybe even bluish color. Some of them a reddish color. And the fact that you have a lot of them in one field gives you a lot of contrast, and the colors actually stand out better. So I am really happy you joined me for this redo of the original Messier Marathon Zoom session. So I'm going to end this one, and I hope you can join me for the second part of this.